Questions 21 through 25 on the 2019 Grade 8 Gauss Math Contest. In Jen's baseball league, each team plays exactly 6 games against each of the other teams in the league. If a total of 396 games are played, how many teams are in the league? Before I jump right into the solution, let's just give an example to illustrate how this would work. Let's say there's 5 teams, A, B, C, D, and each team plays each other. So A plays B, A plays C, A plays D, A plays E. And then B plays A, but I don't need to include that because that's already included. So I'm just going to write B plays C, B plays D, B plays E. C plays A and B, but those are already written. So I just need to write C plays D and C plays E. And the very last one, D plays E. So if you count all these are 10 games. 5 teams, 10 games. Now, if there's 30 teams, are you going to write it all out? Of course not. It would be way too time consuming. So what is the system? Well, there's 2 teams in each game. How many choices do I have for the first team? Well, in this particular case, I've got 5 choices since there's 5 teams. For the second team, how many choices? Well, 4 choices. So 5 times 4, which is 20. But this is 10 because you have to take that 20 and divide by 2. And the reason you have to divide by 2 is because this 20 double counts. It counts AB and BA. And this is the same game. So it double counts. That's why you divide by 2. Okay, so knowing that, we go back to our question. We have this time not been given the number of teams, so I'll just call the number of teams n. We have each game involving 2 teams. For the first team, I have n choices. For the second team, I have n minus 1 choices. So I have to multiply them and then divide by 2, and that has to equal the total number of games. But here's the thing. They have 6 games against each other. In my example here, there's only 1 game against each other. So I just got to put a 6 out front like that. And that totals 396. So this is the math. First, let's just figure out the numbers. So 396 divided by 3, and that is going to be 132. And then I don't think you need to do a quadratic. This is a grade 8. So the easiest way is just take your calculator and take the square root of this, and then it'll give you a certain number, and then use numbers in that vicinity. Use integers in that vicinity. And when I do, I get 11 and 12. So plug in 11, see what happens. Plug in 12, see what happens. And when you plug in 12, you'll see it will work. It'll be 12 times 12 minus 1, which is, of course, 12 times 11, and that is indeed 132. So n is equal to 12. So number 21, the answer is A. Rich chooses a 4-digit positive integer. He erases one of the digits of this integer. The remaining digits in their original order form a 3-digit positive integer. When Rich adds this 3-digit integer to the original 4-digit integer, the result is 6031. What is the sum of the digits of the original 4-digit integer? I will call the 4-digit integer A, B, C, D, where A, B, C, and D are digits from 0 to 9. A, of course, can only be from 1 to 9 because A can't be 0. But B can be from 0 to 9, C can be from 0 to 9, and D can be from 0 to 9. Okay. And then we have to erase one digit. I don't know which digit they're going to erase. And I don't think it really matters. So I'll just erase D. And then when you do, you get A, B, C, and that becomes a 3-digit number. And the question says that when you add these two, this one and this one, you get 6031. Okay, let's go ahead with this. This is 1000A plus 100B plus 10C plus D. This number right here. And then this number is 100A plus 10B plus C. And that's 6031. So now, before we move forward, now it's just sort of trial and error, figuring out what is A, what is B, because we only have one equation. So we've got to use substitution, trial and error, and those kinds of things. There's not enough equations to get formula to work here. So I think A could be 6, right? Because it's 1,000 times A is equal to 6031. And I think that's a decent choice. The only problem is if A is 6, then that means all of this got to equal 31. And I don't think that is going to work, because that would mean this would have to be 0, this would have to be 0, but that's 6, so that doesn't work. So I think A is 5. If A is 5, this becomes 5,000. So that means all these guys, and I can combine them, 100 B plus A, factor out the 100, 10 times C plus B, factor out the 10, and then D plus C. That's going to be 6031 minus 5,000. And that is 1,031. Okay, I'm pretty confident about my choice for A. Now let's continue in the same way. A is already 5, so instead of that A, I should say, I can just put a 5. Okay, so 100 times something is going to be part of that 1031. Now, if B is 5, then that would mean this is going to be 10 times 100, which is 1,000. Okay, that seems like a pretty decent choice. That means all of this would be 31. And I think we're going to run into a problem here, because that's already 5. Even if this is 0, that's not going to work, because this is going to be 50, and 50 is already greater than 31. No problem. That's what trial and error is all about. So instead of 5 for B, let's try 4 for B. I think that might be a decent choice. So let's try B equals 4. If that is true, then this becomes 5 plus 4, which is 9. Then 9 times 100 is 900. So that means that we have to take away 900 from this guy. And when we do, we get 131. And that's equal to what's remaining. So 10 times C plus B, which is 4, plus D plus C. Okay, so same thing. We got to now fiddle around with these numbers again. And these two are individual digits from 0 to 9. So the maximum they could be is 9 and 9. And if they are, then this would be 131 minus 18, which is 113. So that makes me think that this has to be at least 120 in order for that to work, if you do the math. Because if it's 110, then this has to be 21, and there's no way you can get two digits to add up to 21. So that's got to be 120, this thing. If that is 120, then that means C's got to be 8. So if C is 8, it would be 12 times 10, which is indeed 120. And therefore this, D plus C, would be 11. And since C is already 8, that means D is equal to 3. So I hope you see how I did that. It all should work out, but let's just test it out. My ABCD is 5, 4, 8, and 3. And then my ABC, when I chopped off that D, was 5, 4, 8. And then let's see, when I add those two numbers, I get 6031. There you go. It works out. Now what do they want? The sum of the digits of the original 4-digit. Okay, no problem. Sum of the digits of that is 5 plus 4 plus 8 plus 3. And that is equal to 9 plus 8, which is 17, plus 3, which is 20. So number 22, the answer is B. If n is a positive integer, the notation n exclamation mark, read n factorial, is used to represent the product of the integers from 1 to n inclusive. For example, 5 factorial is equal to 1 times 2 times 3 times 4 times 5, which is 120. Which of the following is equal to a perfect square? Well, let me start with a simple example. Might as well just talk about the one that they put in the question stem. 5 factorial can be written as 5 times 4 times 3 times 2 times 1, as they have illustrated in the question stem. But notice I can group these. 5 times 4 factorial. So similarly, with the answer choices, 20 factorial can be written as 20 times 19 factorial. And then I've got a 19 factorial, and I've got that over 1. That is answer choice A. Answer choice B, in a very similar way, would be 20 times 19 factorial times 19 factorial over 2. C, again, 20 times 19 factorial times 19 factorial, this time over 3. D, again, 19 factorial appears twice. The 20 factorial, 20 just by itself appears once over 4. And then finally E, by now you totally get the hang of it. 20 times 19 factorial over 5. Okay, one of these is a perfect square. So which one? Well, A becomes 20 times 19 factorial squared. If this is a perfect square, this would have to be a perfect square, and this would have to be a perfect square. This is because it's something squared, but 20 is not a perfect square, so A is not the right answer. The next one, if you do the division, it becomes 10 times 19 factorial all squared. For this to be a perfect square, both of these would have to be perfect squares. This is not. So B is gone. How about C? 20 over 3, well, that's not even an integer. It's 6 point something. I'm just going to leave it as 20 over 3. 19 factorial all squared. Again, this and this both have to be perfect squares. This is not. That's not right. Now let's go to the next one. 20 divided by 4 is 5. And therefore you got 5 times 19 factorial squared. 19 factorial is a perfect square. 5 is not. Well, the answer's got to be E, but let's see what happens with E. Why is E the right answer? Well, 20 divided by 5 is 4. Then we have 19 factorial squared. Both of these would have to be perfect squares. 19 factorial is, and so is 4. 4, as I'm sure you know, is 2 squared, and then that is also a square. Or you can combine them. 2 times 19 factorial, all squared, like that. Whichever way you want to do it is fine, but we have definitely proven that of all the answer choices, E is the only one that is a perfect square. It's a very cool question. I like it. Number 23 is E. There are many ways in which the list 0 to 9 can be separated into groups. For example, this list could be separated into the 4 groups 0, 3, 4, 8, and 1, 2, 7, and 6, and 5, 9. The sum of the numbers in each of these 4 groups is 15, 10, 6, and 14 respectively. In how many ways can the list 0 through 9 be separated into at least 2 groups so that the sum of the numbers in each group is the same? Well, the first thing we need to do is figure out how many groups there are going to be. Can there be 2 groups? Well, there's 10 numbers, right? And I want to figure out what is the sum of those 10 numbers. So the sum is just going to be 9 times 10 divided by 2, which is 45, right? You know that formula, n times n plus 1 over 2, where n is the last number in consecutive numbers. Even if you didn't, you can just add them all up, and it's going to be 45. The sum of all those numbers is 45. If there's 2 groups, then that means each group must have the same sum, which would, in this case would be 45 divided by 2, which is 22.5, and that's not possible because the sum has to be an integer. The only way you're going to get integers is if there's 3 groups, or if there's 5 groups, or if there's 9 groups. The maximum number of groups can be 10 because there's 10 numbers, and that's if there's 1 digit in each group. If there's 3 groups, then the sum of each group would be 45 divided by 3, which is 15. Okay, that's good. If there's 5 groups, the sum of each group would be 45 divided by 5, which is 9. If there's 9 groups, then the sum would be 45 divided by 9, which is 5. If there's 9 groups, however, I really don't think this is going to work, because there would be 9 groups with 1 digit each, and then each of those digits, there's no way there's going to be a sum of 5. So that won't work. So I'm just going to get rid of that one. So it looks like the only way we're going to work out the solution is by using either 3 groups or 5 groups. Okay, I'm going to start with the 5 groups first, because I think that's a little bit easier. So here we go. 5 groups. If there's 5 groups, what kind of situation will we have? Well, first of all, there's 10 numbers. So if there's 5 groups, I think each group will most likely have 2 elements in it. And the sum of each has to be 9. So the 9 is going to be paired with the 0. And then the 8 has to be paired with the 1. 7 has to be paired with the 2. 6 has to be paired with the 3. And the 5 has to be paired with the 4. So these are the groups. 1, 2, 3, 4, 5 groups. And each group has a sum of 9. So that works. And that is definitely 1. But here's the thing. The 0 right here can be put in any of the other groups. For example, it could be put here, 0, 1, 8. And the remaining groups stay the same. Do you see how by putting the 0 in another group, it still remains valid? And similarly, the 0 could be placed here or here or here. So we actually get 5 different groups here. 5 different sets, I should say. Okay, and that pretty much takes care of this category right here. Now we move on to the 3, where there's 3 groups. And when there's 3 groups, that's going to be a little bit more complicated. Okay, when there's 3 groups, the sum has to be 15, right? So I got 3 groups, and each group has to have a sum of 45 divided by 3, which is 15. Okay, so I'm just going to put 1, and then we'll work off that one. Sum is 15, so the 9 has to go somewhere, and that most likely could be paired with 6, and I'm going to stick the 0 in there. And then the 8 has got to be paired with the 7, and then everything else goes into the third group, which is 1, 2, 3, 4, 5. And does this add up? That adds up to 15, that adds up to 15, and that does add up to 15. Okay, so we got 1 group. But remember, just like before, we can put the 0 here or here. So every time I list something, it actually is listing 3 groups. 1 group with the 0 here, 1 group with the 0 here, 1 group if I put the 0 there. Okay, so now what I'm going to do is, based on this first one, we'll try to create more. All right, so the strategy is really looking at the numbers and saying, I put a 7 there. Can I put something else other than the 7 that adds up to 7? And if I do, I will have created another set. So for example, I'll just give you the first example. 7 is actually equal to 5 plus 2. So I can put a 2 and a 5 like that instead of the 7. But if I take the 2 and 5 out of there, I got to put a 7 instead. So that becomes 1, 3, 4, 7. Do you see how I did that? And that's pretty much what we have to do in this question, is figure out what can I put here and what can I put there that pretty much equals the same thing. And as always, each of those gives me 3, because you can put the 0 here or the 0 here. All right, so that is another 3 that I got. And I'll just walk you through a couple more, and then I think I'll just list them all, because you don't need to hear me go through every single one, because I mean, you guys can figure this out. But I'll just do a couple more. Is there anything else I can do with the 7? I did a 2 and a 5. Well, I think 3 and a 4, that would work. So instead of a 7, I'll put 3 and 4, and then keep that 8. And I'll leave this 6, 9 as it is. But if I put a 3 and 4 in this column, or this section, I got to take it out of there, so that's going to be 1, 2, 5, and 7. And of course, that gives me 3 new. And I'll do one more. One more. So again, if I'm going to take out the 7, I've got to put something that equals 7. And I think I can squeeze one more. 1, 2, and 4 would do it. 1 plus 2 plus 4 is 7. So if I put 1, 2 and 4 and then leave that 8 in there, that would also add up. And if I take the 1, 2, 4 out of there, I've got to leave just the 3, the 5, and the 7. And there you go. That's the strategy. So now, as promised, I will just list the rest instead of, torturing you with what is by now something that I'm sure you have become an expert on. And there you go. The strategy is exactly the same. So I encourage you, take out a piece of paper and practice this. It's a good question. Now we just got to add up all these. And what is that? 5 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3. So that's 27 plus 5, which is 32. 32 different sets. And that would mean to number 24, the answer is E. In quadrilateral PQRS, diagonals PR and SQ intersect at O inside PQRS. SP is equal to SQ is equal to SR is equal to 1. And angle QSR is equal to 2 times angle QSP. Mark determines the measure of 12 angles that are the interior angles of triangles POS, POQ, ROS, and ROQ. The measures of each of these angles in degrees is a positive integer, and exactly 6 of these integers are prime numbers. How many different quadrilaterals have these properties and are not rotations or translations of each other? We need a big version of the diagram because this question is all about angle chasing. And angle chasing is very common on math contests, and they oftentimes put these kinds of questions in. So here we go. We are told that this angle is twice this angle. So I'll call this 4 theta and I'll call this 2 theta. That was given in the question. Now the rest I've got to figure out. But there's some good news. We are told that this is equal to that is equal to that. So they've got some isosceles triangles, right? So let's start with this one here. If this is isosceles, this is going to be equal to that. I'll just call them X for now. So from the first triangle, I know that X plus 2 theta plus 4 theta is equal to 180. So that means 2x is equal to 180 minus 6 theta, and therefore x is equal to 90 minus 3 theta. Okay, I'll put that in here, 90 minus 3 theta. And this one also, 90 minus 3 theta. Let's keep going here. We got quite a few angles to get. So where do we go next? We have another isosceles triangle, this one right here. And therefore this angle has got to be the same as that angle. This angle I called x, so this angle here I'll just call y. And therefore this was going to be x plus y, right? Because this angle is the same as that angle. Okay, again, angle chasing. So let's see, I guess we're using this triangle. So that means 2 theta plus x plus y is equal to 180. And x we actually know. So it's 2 theta plus 2x, but x is 90 minus 3 theta. So that would be 180 minus 6 theta plus 2y is equal to 180. So that means 2y is equal to 4 theta, and therefore y is 2 theta. Okay, that's a pretty good result. So that's 2 theta right there. And I guess x plus y would be 90 minus theta. So there we go. Okay, where do I go next here now? Might as well figure out this one. I'll just call that Z, and by opposite angles, that's going to be Z. Yeah, that's a pretty good way to go about this. And then we can just use this triangle. So in that triangle, more angle chasing, 2 theta plus 90 minus theta plus z is equal to 180. So let's see what that gives me. Z is equal to 90 minus theta. Okay. 90 minus theta. And this one also, 90 minus theta. Where do we go next here? W is the letter I guess I'll choose for this and this. Those will be both W's. W and W. And for W, I guess we can just use the whole way around, that everything is going to be 360. So 2W plus 2Z is 360. And then 2W, well, Z is this guy, 90 minus theta, so 180 minus 2 theta is 360. So 2W would be 180 plus 2 theta, and therefore W is 90 plus theta. All right, 90 plus theta for W. Do I have any? Yeah, I got to get this one and this one. Okay. All right. Okay, the good news is that's part of this isosceles triangle. Okay, that is indeed good news. So this angle here, I'll just call whatever V, and therefore this has got to be the same as this one. So this angle will be X plus V. And I think that's it. That would be the last one. All right, here we go. Last angle chasing formula. And which are we going to use here? I guess we can just use the big one, that whole triangle. So that means 4 theta plus x plus v is equal to 180. And then we figured out one of these, right? X, yeah, we figured out x a long time ago. So 90 minus 3 theta. So this is going to be 4 theta plus 2x, so that's going to be 180 minus 6 theta. Plus 2v is 180. So that looks like 2v is going to be equal to 2 theta, and therefore v is equal to theta. All right, that's a pretty good result. So I think I have them all. I have them all, and we'll just make a list now of all my angles. I've got, let's just keep the diagram in the picture here because I've got to use it. Let's see here. In this triangle, I've got 2 theta, 90 minus 3 theta, and W. And what was W? W was 90 plus theta. All right, 90 plus theta. And then in this triangle here, I have 4 theta, X, which was 90 minus 3 theta, and Z, which is 90 minus theta. Okay, and then in this triangle, I've got V, which I just figured out was theta, and then X plus V, which I guess would be, X is 90 minus 3 theta, and then V is theta, so 90 minus 2 theta. And then the other angle is W, and W is equal to 90 plus theta. And then the last triangle, which is this guy, those angles are Z, which is, or Y, which is 2 theta, and then Z, which is 90 minus theta, and then X plus Y, which is 90 minus theta. All right, great. These are the 12 angles. Now, there's 12 angles, but some of them are repeats, right? So, for example, theta is listed once. 2 theta is listed twice. 4 theta is listed once. 90 minus theta is listed 3 times, actually. Yeah, 3 times. 90 plus theta is listed twice. 90 minus 2 theta is listed once. And finally, 90 minus 3 theta is listed twice. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12. Okay. Now, the rule is that 6 of these must be prime. 6 of these have to be prime. And we've got to figure out how to do that. Okay, so let's make a table with these angles. Here we go. Now, I got to start somewhere, right? So I'm going to start with theta, and I've got to make sure that they're prime. So we're going to start with prime numbers. And the first prime number, of course, is 2. And then I'm just going to list prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and hopefully, I don't have to go beyond that. Now here's the thing. This is a big table and it's very time consuming, right? The math is not that hard, but it's just time consuming. But some of these I don't need to fill out. Why? Well, because 2 theta is not going to be prime. It's divisible by 2. It's 2 theta. 4 theta is obviously not going to be prime because it's divisible by 4. So I don't need to worry about those guys. 90 minus theta, 90 plus theta, that one I need to figure out. 90 minus 2 theta, you can factor out a 2. So that's going to be divisible by 2. That can never be prime, therefore. And 90 minus 3 theta is going to be divisible by 3. You could factor out a 3. So the only columns I need to figure out are this one, and this one. So that's what I'll do. So we got 88. And the math now is very easy, right? So it makes it very quick that we can do this. 85, 95, 83, 97, 79, 101, 77, 103, 73, 107, 71, 109, 67, 113, 61, 119. Now we want a situation where we have at least 6 primes. Okay, well, there's only one of these guys. 90 minus theta, there's 3 of those. And 90 plus theta, there's 2 of those. So if we have prime, prime, and prime, we'd have 6, because it'd be 1, 3, and 2. Okay, let's see. Which one of these are prime, prime, prime? And when I look through the list, I think we have a right here. This one, the 19 gives me, so does 23, and so does 29. Is there any more? And the 11 one, this one also. Yeah, that'll do it. This is divisible by 2, that's not prime. 9, this is divisible by 3, this is obviously divisible by 5. And 77 is obviously divisible by 7, so those are not primes. So that's it, I get 6. And if you keep going, you'll find that you won't get any more. All right, we're done. Time consuming, definitely. So 6 I got. And therefore, the answer to number 25 would be choice D.